Hello guys, welcome back to the part 2 of this chapter, some basic concepts of chemistry. So now our next topic is prefixes used in the SI system. So here are some prefixes listed below. You need to learn these prefixes and that is it. Now our next topic is mass and weight. So basically mass is the amount of matter present in a substance, while weight is the force exerted by gravity on an object. Next is volume. Volume is the amount of space occupied by a substance. Our next topic is density. It is the amount of mass per unit volume. Here is the formula of density and the SI unit of density is kilogram per cubic meters. Now our next topic is temperature. So there are three common scales to measure temperature, which is degree Celsius, degree Fahrenheit and Kelvin. Here are the formulas to measure degree Fahrenheit and Kelvin scale. Now our next topic is uncertainty in measurements. So let's first understand accuracy. So accuracy describes the closeness of a measurement to its true value. Now let's say, for example, your true value is given as 4. Now what is its accuracy? So accuracy is basically the closeness of measurement to the true value. So for example, our measurement we are getting as 3.99. So now this is close to the true value. Therefore this is accuracy. Now let's see precision. Precision describes how closely the different measurements of a given quantity agree with one another. For example, let's say the true value is 4 only and we are getting 3 different measurements such as 3.6, 3.7 and 3.8. Now here we can see that these 3 measurements are showing closeness to each other, not to the true value. Therefore this is your precision. Now our next topic is scientific notations. So now this is an exponential notation in which any number can be represented in the form of n into 10 to the power n, where small n is an exponent having positive values and can vary between 1 to 10. Now here we can see that decimal, when it moves to the left hand side, then the power gets increased, while when it moves to the right hand side, the power gets decreased. For example, we have an example 232.508. Now here power will move to the left hand side, so we'll write it is moving 2 digits to the left hand side, therefore we'll write 2.32508 into 10 to the power 2. Now let's understand some rules to determine the significant figures. So our first rule is that all non-zero digits are significant. For example, let's say 2.435. Now here all the digits are non-zero. Therefore here there are 4 significant figures. The next rule is ending zeros in the right of the decimal is significant. For example, let's say 56.0. Now here 56 is basically a non-zero number, therefore these two are significant, and this 0 is placed on the right hand side of the decimal and this is an ending 0, therefore this is also significant. Therefore here there are 3 significant figures. Our third rule is that all the zeros between 2 non-zero digits are significant. For example, let's say 2.020. Now here 2 is a significant figure as it is a non-zero number, and here 0 is also significant because it's placed as an ending 0 on the right of the decimal point. Now between these 2 significant figures there are 2 digits, 0 and 2. Therefore according to the third rule, these 2 are also significant. Therefore there are total 4 significant figures in this case. Now our fourth rule is that initial zeros are not significant. For example, 005. Now here these 2 initial zeros are not significant, just 5 is significant. Therefore there is only 1 significant figure in this case. Our fifth rule is that exact number have infinite number of significant figures. For example, 2 bags. Now this is an exact number, therefore it will have infinite number of significant figures. Our sixth rule is that when the number ends in 0 and 0 is not placed on the right of the decimal point, then such zeros may or may not be significant. For example, let's say 200. Now here 2 is a non-zero number, therefore it is significant, but these two are not placed after the decimal point, therefore these two are not significant, therefore there is only one significant figure in this case. Our seventh and the last rule is that power of 10 is not significant. For example, let's say 3 into 10 to the power 8. Now here 10 to the power 8 is not a significant figure, therefore only one significant figure is here, that is 3. Now our next topic is addition and subtraction of significant figures. Let us carry out the addition of three numbers 3.52, 2.3 and 6.24 having different precision or different number of decimal places. After the addition of these three numbers, the final result has two decimal places, but the answer has to be reported only up to one decimal place. Therefore, the answer would be 12.0. Now our next topic is multiplication and division of significant figures. So first let's see the multiplication. 2.2120 into 0.011. The answer we are getting as 0.024332. But the final result should be reported up to the same number of significant figures as present in the least precise number. Therefore the final result would be 0.024. Same process would occur in case of division. Now here 4.2211 divided by 3.76, the answer is getting out to be 1.12263. Therefore the final result would be 1.12. So guys, this is it for today's video of part 2. We'll meet in the part 3 of this video where we'll cover the laws and some more topics. Thank you for watching. Bye bye.